2 questions. Are you split testing to improve your conversion rates? And are you losing money by doing it wrong? Everyone knows you need to split test, but that doesn't mean everyone does it, and it certainly doesn't mean everyone does it right. Split testing is when you simultaneously run 2 different versions of a banner, a web page, an order form, or some other piece of direct response advertising, and compare their conversion rates to decide which one is more effective. But how do you know when you've gathered the right amount of data to make that decision? If you don't wait long enough and gather enough data, you may get invalid numbers, pick the wrong winner, and lose money by keeping the less effective version. But it's also possible to run a test too long. It doesn't invalidate your results, but it wastes time that could have been used running a new test to make even more improvements, and you lose money by keeping the ineffective version around for too long after you should have known that it was time to move on. To avoid both of these mistakes, running your tests too short or too long, you have to run your tests through the right statistical formula. I'll tell you about a free tool you can use to do that in a minute, but first, if you're either winging it or using some rule of thumb to decide when to end your tests, let's test your method and see if it's accurate enough to avoid costing you money. Statisticians recommend that you run your tests until, according to their formula, there's less than a 1 in 20 chance that your results could be wrong, or in other words, you reach the 95% confidence level. Let's look at a few scenarios. See if you can tell whether we've gathered enough data to choose a winner. First, we have 2 alternatives, 150 impressions each. One has 5 conversions, or 3.3%. The other has 14 conversions, or 9.3%. Do we need to keep this test running? Has it run long enough? Or has it run too long? It's run long enough. With this data, we're 96.84% confident that the second version will continue to outperform the first. You may be surprised to see that with so little data, but the conversion percentages are far enough apart for us to pick a winner. Just to be clear, we don't know how much better the second version is. It may be nearly 3 times as good as our current data suggests. Then again, if we kept running the test, the numbers might even out a bit, and it could end up being only 10% better, or it might pull even further ahead. The only thing we can say with confidence, with 96.84% confidence, is that it is better. Next, again, 150 impressions each, but this time, instead of 9 more conversions, the leader has 15 more conversions. Has this test not run long enough? Or is it just right, or has it run too long? Not long enough. Our confidence score is not quite to 95% yet. If you're wondering how this test cannot be ready to call when the difference in conversions was greater than in the first scenario, you need to look at it differently. In the first scenario, the leader was converting nearly 3 times as often as the trailer. This time, the difference between the number of conversions is greater, but it's the smaller multiple. It's not 3 times as often, it's not twice, and it's not even quite 1.5 times as often, and that's why we can't end this test yet. Next, let's look at some bigger numbers. 100,000 impressions each with 1,523 versus 1,633 conversions, or 1.52% versus 1.63%. With a difference of 0.11%, what do you think? It's run long enough. We're 95.16% confidence that the difference, as small as it is real. Again, 100,000 impressions, but this time 9526 versus 9312, and the conversion rates are 0.22% apart. What do you think? If you guess that this is like our first 2 scenarios, you're right. Our confidence score is only 89.86%, not enough to name a winner. However, unless you're getting tens of thousands of impressions a day, with this much data, you may want to end the test, because what the numbers may be telling us is that neither version is really that much better than the other. So you can pick whichever one you think provides the best foundation for future improvements. Okay, let's do 4 more. 5,000 impressions each, 948 and 882 conversions. Not long enough? Just right? Or we've run too long? We've probably run this test too long. Our confidence score is already over 99%. So we're wasting time that could have been spent on the next test or running our winner full time. Next, let's go back to some smaller numbers. 300 impressions, 58 conversions versus 42 conversions. What do you think? Not long enough. We're only at 92.11%. Next, we'll keep the 300 impressions and 100 total conversions, but give the leader one more and the trailer one less. Is that small a change enough to make a difference? What do you think? It is. We're now over 95%. And finally, let's keep the same number of conversions, but check the results if we have 100 more impressions for each version. With that much more data, have we run the test too long, the right amount of time, or not long enough? Not long enough. More data does not always mean more certainty. If that surprised you, that's why you always need to do the statistical analysis, not just trust your gut or a rule of thumb. If you got all of the answers right, then I am impressed. Either your method or your intuition is pretty good, or you're having a very lucky day. But I'd still encourage you to do statistical analysis of your split test results to be sure that you're making the best possible calls when your business is on the line. If you don't have a statistical analysis tool that's connected to whatever system you're using to run your split tests, you're welcome to use my free split test analyzer. You'll find it on whitehatcrew.com under the Tools menu, or at iaago.com/rfc. If you'd like to know what the results you get from statistical analysis tools really mean, how we can say we have 95% confidence, for example, without having to understand the math, in an upcoming video I'll dispense with the complicated formulas and show you in a very clear visual way how and why statistical analysis works.